I realized that in my last video, we did not get a graph. We did not get a chance to look at the graph of this expression, and also realized that I had incorrectly entered this expression. So when I go and look at this and try to make a correlation between the expression and the graph, remember I entered my graph, and what I had done in here was entered it incorrectly, so I wasn't seeing everything. But I wanted to illustrate some important features of this. Okay, first off, okay, when this was factored, here's the expression, and when factored, we've determined that x can equal those values of 0, 4, and -1. Okay, the implications of those things on the graph is one thing I want to illustrate. Also, we know that 3 and -3 make the numerator go to 0. Okay, so and I've told you, and I've caused you to lose a point for not writing these expressions that x cannot equal those values, and now I want to show you part of the reason behind that. Okay, so the graph is in a very small window, and even within that window, so it's a very tight window in y, as you can see, between -1/2 and +1/2. Okay, and probably I could even tighten that a little bit more in x. Okay, but that's not really going to matter much. Okay, so we're going to take a look at the graph now with that tightened window and see if we can pick off those things. Okay, you're probably wondering, why are these vertical lines there? Well, they're exactly at these locations that the graph can never equal. So it can never equal 0, can never equal -1, and it can never equal 4. And so those vertical lines are more or less, they're called asymptotes. They're not part of the graph, they're guidelines. So the graph approaches this vertical line on left and right of this value of 4 here. And as you can see, okay, from here we've identified a positive region from -3. Now you say, I don't even see the graph. No, it's probably riding the axes all the way out. But we'll look at our table and try to determine that. And it definitely goes negative, okay, between the -3 and the -1 here. And then you're saying, well, between 0 and 1, I don't even see it. No, you don't, okay, because it's probably north of this 1/2 cutoff that I imposed there. Okay, then we're positive again from 0 out to this intercept of 3. Then we dip negative between that intercept and this asymptote here, and then we go positive. So I just want to illustrate for you on the using the calculator how we can take a look at that from the numbers. Okay, so we're going to look at the table. Okay, we're going to look at the table. Now, before we look at the table, we have to set it up. Okay, so if we diamond F4, look at a table set. The table set will tell you, where do you want to begin. Okay, let's say I begin out here at -4. Okay, so let's get that in. Begin at -5. Okay, and the increments I'm going to make at 0.5. So 0.5. Okay, and then we're just going to leave the rest of that alone. We're going to enter that, and now we're going to come and ask to look at the table. So we diamond F5, look at the table. Let's try that again. Diamond, escape. Diamond F5 to look at the table. So here we are, going up to +3. All these values, as small as they are, okay, and you can go out further. Doesn't really matter. You can see all those values, the y values, are remaining positive. Very small positives, that's indicative of what we suspected. It's riding the axes. Okay, then at 3, negative 3 rather, it's become 0. We knew that. Between negative 3 and 1, the x values between negative 3 and 1, this thing dips negative. Okay, remaining negative. At negative 1, it's undefined. Yes, because it causes a 0 in the denominator, which is an asymptote. Okay, then between negative 1 and 0, not that we have only but 1 point to sample, it does go positive. Okay, so it is positive, and then it's 0 again. It's undefined. That's the asymptote. That's the 0 occurring in the denominator. Okay, and then we're going positive between 0 and 3. The x values between 0 and 3. This should remain positive. It does. It is. Here it hits 3 where it becomes 0. Now between 3 and 4, it should dip negative. Okay, and we only have that one sample value, but certainly it's dipping negative. And at 4, there's another point, which is an asymptote, occurring a 0 in the denominator. Okay, and certainly you can see it's undefined. And then from there on out, okay, from there on out, we should be positive thereafter. Okay, so hopefully you get a lot out of this. Okay, the graph is not necessary. It's not, and the calculator is not necessary for these exercises. It's merely in there to kind of illustrate where this is going to take us, because invariably being able to generate these sign tables is going to help us in constructing these graphs. Okay, and a graph of this sort is it's called a rational function graph, which we actually won't be getting to until about chapter 5, I believe. Nonetheless, I mean, it's certainly something that we can bear in mind to look in terms of what we'll be looking at down the line. Okay. All right. Hope that proved helpful to you. Okay. So I hope you're going to be okay in watching these videos and then doing the subsequent exercises. That's it for today.